Welcome back to our video lecture series on system dynamics and vibrations. Today we're going to be introducing a new topic of control um, and controlling a dynamic system. Uh, when we talk about controls or control science, what we're doing is if we have a dynamic system with x double dot plus 2 zeta omega n x dot plus omega n squared x, for example, equals f of t. Um, what controls does and what the fundamental problem is that we try and solve with control science is how can we pick a force F such that the system does what we want it to do. Um, and in this class, in this video, we're going to give a very brief introduction into how we can do that, how we can pick that force, and how we can analytically and make an informed decision based on our analysis of dynamical systems. Um, and there are entire classes on control, but we're going to give a brief introduction and overview in this class. Um, so to continue thinking about what exactly it is, what exactly controls is, if you've ever used a car with cruise control, if you've ever used cruise control in a car, um, you know something about control, where you have some desired speed of the car, V desired, and maybe you're on the freeway and you're following the speed limit in Florida, so that is going to be 70 miles per hour. And you set that speed at 70 miles per hour, and then you stop touching the gas pedal. Once you stop touching the gas pedal, your car now has to decide and has to um, apply that gas pedal, open up or run the cylinders if it's an electrical car, run the motors, um, just just right to maintain that speed. And sometimes your car is going to be, uh, sometimes it's going to find itself on a hill and it's going to slow down suddenly, and your car will need to step on the gas a little more to overcome that. Sometimes, maybe you're going downhill or or just a tailwind starts and your car starts to go faster than that, and your car's going to need to hit the brakes. And so that idea is disturbance rejection. So there's a hill that causes your car to slow down. There's some wind that causes it to speed up. That would be a disturbance that keeps you from maintaining the desired 70 miles an hour speed. And a big chunk of what we do in controls and picking that force is allowing that force to respond to disturbances and maintain a constant velocity of 70 miles per hour. Um, we can also talk about the speed of response. So if you're going 50 miles an hour and maybe your car is more modern, you have some sort of digital cruise control. You're going 50 miles an hour and you tell it to immediately go 70 miles per hour. Now, there's a few ways that your car could go about doing that. Your car could slam on the gas to try and get from 50 to 70 as quickly as possible, right? But that would probably be pretty uncomfortable for the user, you, and all of your passengers. So we can also use control to shape a response where we have some desired speed or something or position that's not where we're currently at, and how do we shape the response to meet our desired requirements? For example, that the people be comfortable in the car. And so far in this class, if a system is underdamped, if a system is going to respond with an um, underdamped characteristics to an input, that's part of the physical characteristics of the system, and there's not actually anything we can do to change that beyond going in, changing parts, changing the system. And but if we pick this force f of t correctly, we can actually change an underdamped system into maybe a critically damped system or even an overdamped system and vice versa. We have some decisions and some level of choices that we can make to uh, change the behavior of a system just honestly with a computer with a couple lines of code. Um, so we've talked about the example of cruise control. Another maybe a simpler example um, is a thermostat, where I hope all of you have functioning thermostats in your house, especially if you're local here in Florida, um, where you have a thermostat and you set some desired temperature, right? You have some T desired, and maybe that's equal to 68 degrees. Um, and your thermostat is a sensor that can measure the temperature inside your house, and if it gets hotter than 68 degrees, it's going by maybe with some air tolerance, then it's going to turn on the air conditioner. And if it gets colder than 68 degrees, it's going to turn on the heater. So that F of T is some combination of fans and air conditioners and heaters that uh, work together to keep your house or keep your apartment at some desired temperature. So I hope that um, we're kind of starting to get an idea of what control systems it are, what the problem that we're trying to solve is. But we're going to go ahead and close and end this video now, and we'll dig into the process of controls in the next video.